Today we're going to continue to talk about transformation of quadratics, but instead of looking at h and k, we're going to look at that third piece, which was the a. So we've been talking about x minus h quantity squared plus k, and we talked about k was our up-down, h was our left-right. So today we're going to talk about a. And you will need your calculator for this piece today so that you can see what's happening. If we're going to complete our table for, remember this is our parent function. This is the one that we compare everything to. So we have 1, 0, 1, 1, and then we have 4. So what we're going to look at today is what happens when we change a. So we're going to go ahead and put in our parent function y equals x squared. And then we can hit tab, and now we're going to compare it to 2x squared. Now when we did this originally, we thought, oh man, it's at times 2, it's going to get wider, but in fact you can see on this red line it actually got thinner. And we had talked about previously in class how that would happen. So if I'm going to go through, then these are going to become 2's and these are going to become 8's. And we can go ahead and look at, we put this on the same graph. Here's our parent function. We're still going to be at 0, 0, but now we're counting over 1, which we can see here, over 1, and then up 2, if we're going to use our counting principle, over 1, up 2. We're going to count over 2 and up 8. And because we multiplied it by 2 and our y numbers got bigger, this is what we call a vertical stretch. It's stretching up higher vertically. So we can compare that. So now when we compare all of these different pieces we've been talking about, our vertex did not change, our domain did not change, our range did not change, our axis of symmetry did not change. The only thing that changed was that it did in fact get taller. Okay, it stretched higher. So when we go to this next page, we should be able to make a prediction now about what would happen here. We know this is 4, 1, 0, 1, 4. If I go back to my calculator, I'm just going to continue to leave that. I'm going to put in 0.5x squared. And we can see on the black line, this is what we call a vertical compression. It's getting closer to that x-axis. It's getting pushed down. So when we look at that, 0.5, 0.5, this is going to be 2 and 2. So the reason that happens is because now we are not counting up as high. We're still going to count over 1, but now we're only going to count up a half. We're going to count over 2, but now we're only counting up 2 instead of that 4 that we did previously. So this is what we call a vertical, a vertical compression, or a vertical shrink. Whereas prior, when we looked at this other one, this was our, oh, I hit a button. This was our vertical stretch. Okay? So when we come down here and we look at this comparison table, again, none of this is going to change. It's all going to be the same. The only thing that is changing is the stretch or the shrink. So when we compare them, describe the pattern that we noticed that on the equation, A is different. Okay. When we looked at our tables, on the y equals 2x squared, y is times 2. Let's not use an x for time. Let's use the word. Times 2, and on y equals 1/2 x squared, the y based on our parent function, y is cut in half. On our graph, 2x squared was thinner, and 1/2 x squared was wider. Our vertex, our domain, our range, our axis of symmetries, those all stayed the same. The change to the parent function on 1 was a vertical stretch, 2 was a vertical shrink or compression. That's how you'll see that in Algebra 2. The vertical stretch or shrink changes the shape of the graph. So when a is greater than 0, how does the value of a change the graph? This makes it a vertical stretch, okay? When a is greater than 0, it's going to become thinner, okay? A change in size or position is called a transformation. Identify the transformations that have been introduced so far in this activity. So the transformation we have done was a dilation, which we talked about in 7th grade, by 2 and 1/2. So vertical stretching and shrinking also applies to linear. Okay, that's a little harder to see. When we look at it in linear, it is going to, we're looking at the slope. Okay, so how do these compare to the parent function? So 2x is going to be steeper. We did that way in the first semester. And 1/2 x is going to be flatter. Because we're still starting at 0, 0, but now we're going up 2 and over 1. We're also going down 2 and back 1. So this is y equals 2x, this is y equals x, our parent function. But if we're going to go up 1 and over 2, or down 1 and over 2, this is going to be our y equals 1/2 x. So based on that, we can look at a couple of practice problems and I'll give you some check for understanding. So if you want to try these, you can pause me and then come back and check yourself. For 7 and 8, predict the change from the graph of y equals x squared for each function. Confirm your predictions by graphing on the same grid. So this is going to be a vertical stretch. This is going to be a vertical compression or a shrink. And then write your equation. So if we have a vertical stretch of 5, we have y equals 5x squared, and a vertical shrink is going to be y equals 1/5 x squared. There's going to be some check for understanding questions. Some of them might be some of these, but please let me know if you have any questions.